Welcome to another episode of the ASME Insights podcast. On ASME Insights, we interview leaders in the engineering field and explore how ASME is staying at the forefront of engineering innovation. I'm your host, Lester Sue, ASME's 144th president, and I'm excited to continue this journey with you as we dive into the future of engineering. Today, I'm joined by our guest Chandrakant Patel to discuss how we can develop the engineering workforce at the local level. Chandrakant is currently president of Chandrakant Patel Consulting, advising on technology strategy. Formerly, he was a senior vice president, senior fellow, and chief engineer at HP, where he worked for 37 years in Silicon Valley. He has served as adjunct faculty in engineering at UC Berkeley, San Jose State, Santa Clara University, and Shabbat College for 2 decades. He is not only an ASME fellow, but also the inaugural recipient of the ASME Foundation's Next Gen Award. It is involved in SME's Community College Engineering Pathways program. Besides that, he's also a member of the National Academy of Engineering and the Silicon Valley Engineering Hall of Fame. Chandrakant, welcome. It's great to have you on the show.
Well, thank you for having me, Lester. I'm really looking forward to our conversation.
Okay, fantastic. So, Chandrakant, I know you have an interesting and maybe unusual path to an engineering career. So if you would just sort of go over your background a little bit and we can get into how that's motivated the work that you do today.
Well, thank you very much, Lester. I think if I look at my childhood growing up, I was always saw America as a land of tinkerers. I saw it was the time when the Queen of the Sky, Boeing 747, was being built. So there was a fascination with engineering, specifically mechanical engineering, that was growing growing up as a child. And when I got an opportunity to come to the United States as an immigrant, I had finished my high school in India. I was 18 years old, and I came as an immigrant to the United States. But coming as an immigrant, I didn't come with any money. In fact, all I had was $20 when I arrived in San Francisco. And I was going to go to my sister's place in Oregon. And I would end up going to Oregon. And in order to pursue my engineering degree, I decided to work, and I found a job in a lumber mill. So it's a wood mulching mill in Southern Oregon, in a city called White City, Oregon, in Southern Oregon. I saved enough money, moved to San Francisco, lived in a low, I wouldn't call it Skid Row, I'll call it like a low income hotel for $150 a month. And quite coincidentally, one day I was at 3rd and Mission in San Francisco, and a bus came by and it said 12 City College. I said, let me go to City College. I go there and I found out that City College is a community college, and that if I did 2 years of coursework, the first 2 years of coursework, then I should be able to transfer to year 3 and 4 at University of California, Berkeley, which is where I wanted to go. So that's what I did. I went to City College of San Francisco, did 2 years, the first 2 years, transferred to Berkeley, finished my undergrad, and then the journey started in Silicon Valley, in earnest, with lots of excitement. So that is basically in a nutshell. And what was interesting was that I didn't get any loan, I didn't get any grants. I was able to work on weekends, and because my high school preparation was so good, I was able to work and put myself through school. And in 4 years, I was able to finish the undergrad. So that told me that the community college system in the United States is extremely powerful, and I'm very thankful to that.
So, over your career at HP, you've seen the emergence of Silicon Valley from sort of its early days of innovation and sort of tinkering in backyards, garages, things like this, to the behemoth companies that we see today. And what do you think about the way the workforce recruiting in Silicon Valley has changed? And are there ways in which we can improve that pathway? What do you see as some of the challenges? I want to keep this sort of very open so we can get your open thoughts about this.
That's a superb question, Lester. And it's very important to look at our history. I spent 37 plus years at HP, but before I came to HP, I was at a company called Memorex. Is it live or is it Memorex? It was Ella Fitzgerald sang and the wine glass broke, and we knew why the wine glass broke. It was that company. Um, and we made the first hard disk drives at Memorex at St. Thomas and Central Expressway, the location where NVIDIA is now located. Design was done locally on a drafting table. Subsequently, CAD arrived. Manufacturing was done locally. Everything was vertically integrated. We went from end to end vertically. In order to do that, people were trained and hired locally. There were technicians, there were apprenticeship programs. All these community colleges became a feeder. And the same was true for chip fabrication. There were chips were designed and fabricated in the United States. In general, it was true that most industries were vertically integrated physically. The systems had sourced parts in the United States and built it. And that was what I would say still machine age, and we were transitioning towards the cyber age. Then what happened uh, is we entered, I think Silicon Valley entered the cyber age. It left the age of hardware tinkering. Remember, I said when I was a child growing up, I thought America was a land of tinkerers. When I started in Silicon Valley, I found myself subsequently at HP with Bill Hewlett and all these guys, and I thought of them as tinkerers. I was in a valley of tinkerers because everything was physically hands-on, done locally. Then, as we moved into cyber age, the valley moved more into above the abstraction layer. With the rise of internet, the latter part of the 20th century saw innovation above the internet, and the focus more became e-commerce, social media, lots of innovation, very interesting innovation at that would start at the computer screen level and then at the phone level. So there was a lot of software innovation. The physical side started to get outsourced, and pretty soon most of the physical side was done outside. I saw a change in pattern of how we hired because large number of people were needed. A lot of the companies found an easier path from sources which had engineers in large numbers, and we saw importation of labor for software work. And then because there was not much physical work, there was not a lot of effort I felt going into using the network of community colleges. So the cyber age was a go-go age, and I call it was, even though we think we are in it right now, I call it a go-go age of economic growth, but it is one that left a lot of the local communities out of the economic growth. And what saddened me was there was a dichotomy where you could see there were people who made a lot of money, and then the ordinary people were left out. But I'm very optimistic about the future of and we can get to that more in a bit. So I just want to talk about the early age, which was a machine age going into cyber. Then the second part was the cyber age, which was largely about the internet, software, e-commerce, social media, mostly value add at the software level. We are leaving that behind and we're entering a new age that I would love to discuss and suggest. Uh, and I'm really excited about it because it's an opportunity to bring people back into the fold. And I have a lot of experience in doing that from my early days when we used to train and hire locally.
I think large companies like your own HP can be spoiled because they have recruiting footprints that extend worldwide, right? HP can plausibly go to any university in the world and say, you're a top engineering student, come to Silicon Valley, work for HP. We'll give you a great salary, great opportunities to work at the cutting edge of technology. And so, can you say a little bit more about the importance of local hiring, even in this context where talent is globally distributed?
Yeah, first, I'm not at HP anymore. I'm retired, but I have seen not only HP but other companies, but largely the software companies have gone all over the world to recruit. Uh, I think, and that was fine in the cyber age. They could get away with. In the cyber physical age, they have to recruit locally because of the solutions they're building. So I think the way to do is to use the playbook from the 80s. Is is to look at the community college as a pipeline and engage not only at the community college level, but at a high school level. Now, how do you do that? So let's look at the numbers. So in my 16 years, I approximately touched 500 students who got jobs in the Valley. Some of them got jobs in the largest IPO uh, that the Valley has had, one of the three top largest IPOs, and at the beginning. So they did much better than even I. And I'm very proud of that. That if my students should drive a Lamborghini, I'll take the public transit. So I am. So if I could touch 500 students, Silicon Valley is all about scale. You and I are about scale. So if there are 1,000 Chandrakant Patels in Silicon Valley, or even 100 Chandrakant Patel in Silicon, don't you think we will create a pipeline, a big pipeline? So you touched on a very, very important point. that I didn't even think about until you asked me this question, frankly. You said adjunct faculty and how important the adjunct faculty is. Even when I was in City College, I didn't have an adjunct faculty, but we had lecturers who came from various places to tell us what they did. So if we had faculty from Boeing Company teaching us about avionics, aircraft design, we had faculty from semiconductor companies, from companies like HP, who did 3D printing and so on, we would be immensely successful with adjunct. And how much time would the adjunct take? I did full time at HP 5 days a week. Sometimes I would come back from overseas, Japan. I remember one day coming back from Japan at close to midnight, and I'd go next morning at 8 o'clock to teach my students, because these students came from all over the community, and I didn't want them to be standing in front of the classroom because Saturday morning there's nobody there and they wouldn't know what to do, and I would feel guilty. Even when my daughter was born, I was there on Saturday while I dropped my wife off and I the hospital, and I went to teach because all I needed was Saturday morning from 8 to 2. So don't you think we owe it to our country and to the students here to have adjuncts who are paid, by the way, and that can add another 8 hours instead of doing frivolous activity? Just go and teach on a Saturday. Uh, we would have immense scale. So that model of training, and in fact, train the trainer model, train the students and who will train others. You hit the nail on the head, Lester. There has to be a model to scale, an adjunct plus train the trainer model, because we don't have a lot of time. We have wasted a lot of time. We turned off hands-on technology courses. There were machine technology courses, welding courses. A lot of them went away. It's in order to bring them back and try to get people in the pipeline in the next 4 to 5 years. That's all we have. There has to be that model. So I think critically, it's going to be important for private sector to have adjuncts, the government to help, and the community college also need to change. They need to focus on guiding the students properly, not just saying go take whatever classes you like. You know, tell them to take focus classes. I still have my catalog from City College of San Francisco here from 1980 and University of California, Berkeley. I used those two catalogs to make sure I took only transferable courses. That's how I did it. Similarly, if somebody wants to do associate of science degree in a particular field, we should give them a set of courses and they stay focused on that. That's the way to do it.
Yeah, Chandrakant, I've heard you speak about the cyber physical age. And, both of us are in Silicon Valley. And so, all the talk here is about AI and software, et cetera. And, I think your own background as a mechanical engineer at a computer company is interesting because I think people forget the importance of mechanical engineering topics. And more recently, engineering or energy, sorry, is the area that we're really focused on just because of the sheer needs that the software world has for energy. And so that, with students especially, it's sometimes hard for them to understand the importance of these mechanical and physical systems to the development of the computer and software technology that we take for granted and that is continuing to sort of explode in influence. So can you speak a little bit to the emergence of the cyber physical age and the reemergence of the importance of physical subjects, and exactly how we can find the workforce for those areas?
Fantastic question. So once again, let's look at the cyber age, which I would say spanned 3 decades, from it's say early 90s to where we are today, even more. The cyber age created such a gold rush that people all wanted to do coding. It's like, hey, if I can write an app or I can do software, I can make a ton of money. Nothing wrong with that. That's what they thought. And most of the people gravitated towards that. We saw excitement at this level. We pressed a button in a car and it autopiloted. And we thought, oh, it is all done by software. Well, wrong. The emergence of now you are seeing these automated vehicles, completely full self driving, is not just a cyber phenomena, it's a cyber physical phenomena. Let's take an example, and that will help define the cyber physical age. When my daughter went to interview at Tesla, and that was in 2014, and she's an industrial engineer. I asked her, go to the whiteboard. By the way, I keep a whiteboard in the family room. The kids used to call it torture at the Patel household because there was a term called waterboarding at that era when they were growing up, and they never wanted to be whiteboarded. But anyway, I tell her to go to the whiteboard, sketch out the car, and size the motor in the car. I say, calculate the wind resistance, it's the velocity squared, calculate the rolling friction, determine the size of the motor approximately. What dominates at 70 miles an hour? Is it wind resistance or rolling friction? And then I said, I went through all the fundamentals of an electric car, physical fundamentals, mechanics of solids, mechanics of fluids, all of that. Then I said, your boss wants to autopilot the car. Remember, this is 2014, autopilot's not around. I said, there's no way he can autopilot in software unless you put the right actuators in place. So, how will you design the car with the right sensor and the right actuator? You'll have to build the physical platform, you will have to have the knobs in it, and you'll have to have the sensors in it. If you do not put the knobs and sensors a priori, no matter what you do in software, it ain't going to autopilot. That is the cyber physical story. There's no way you can build a cyber physical system without putting the right actuators and sensors a priori. That's where the mechanical engineer comes in. Think of intuitive surgical. Think of robotic surgery. Think of robots. Robots don't happen by software alone. You need to think of the physical system, put the right actuators and sensors a priori. So I made her go through that. She ended up getting a job. She got a Model S. And then I said, look at how the company will update the software. And since she was an employee, she even got a alpha version and a beta version of the autopilot. And when she installed it, she could see that it was autopiloting, and she could see how the improvements were occurring. So I told her, see, had they not done the physical platform properly, there's no way they could have autopiloted. And 10 years on, they continue to improve it, the same car. So what that says is, without a physical foundation steeped in fundamentals of engineering, you cannot have a cyber physical system. A cyber physical system is a robotic surgery, a robot, a electric vehicle, a regular vehicle, an airplane, power, water, waste, transport, healthcare, manufacturing, agriculture. Those are all cyber physical systems, and they are important to society. And AI in the future will be applied horizontally across these verticals: power, water, waste, transport, healthcare. The AI that we are dealing with today is interesting. Congratulations. But I want AI to address solutions that matter to society. And the AI must deconstruct conventional business models. Like if you had a surgery that is being done and use AI enabled surgery, that's deconstructing the conventional method of surgery. But while doing so, AI must be more expeditious. AI should have made the solution more expeditious and use less energy than was used before. So the way I see it is, when I see the Golden Gate Bridge, I ask people in Silicon Valley who talk a lot about AI, I ask, do you think if you use AI, you could build this bridge in the same time or less time with less energy? I don't use dollars, rupees, yuans. I say with less energy, lifetime energy, than it took in 1930s to build the bridge. I ask them, can AI build the bridge for less energy today, including the energy the AI solution took? And if the answer is yes, then AI is delivering net positive impact. If the answer is no, then why use AI? So my metric is very clear. Energy, joule is the currency, and net positive impact based on joule is the way to go. So when you look at all of this and you look at the trends, it is clear the future is cyber physical. It's solutions that matter to society. And if you're a student, you better know your physical sciences. And by the way, get breadth in cyber sciences. It's very easy now. It's very easy to get breadth in cyber science. And we can talk a lot about how to get depth and breadth, which gets us into how to prepare for the cyber physical age.
So, Chandrakant, you've been involved many years with ASME, including recently helping to pilot ASME's Community College Engineering Pathways program. Can you talk a little bit to us about that program and how it bridges the technical skills gap?
So I was really honored and thankful that ASME requested me to join that program. So one of the hallmark of that program was to get some pilots going with various community colleges. One of the pilots that was quite interesting was was in Colorado, where Red Rock Community College had a program where they were teaching security, and the security was cyber security associated with uh, critical resources that are delivered in a city. So, water treatment plant, water delivery. How do we make this secure so it cannot be hacked in? I thought that was amazing. Cyber physical security. So, let's just take security for a moment. Hitherto, security has been cyber security. We associated with protecting our credit card, protecting our personal data, and protecting the data on our computers. That's cyber security. But in the cyber physical age, we will need to do cyber physical security, which is securing the power, water, waste, transport. Make sure that all those critical resources cannot be hacked in, damaged, and cause ill to the demand side, the people who are consuming it. That's a critical. So strategically, it made sense that cyber security must become cyber physical security. And this community college had a program where they have they're teaching how to do that for a water treatment plant. So, whoa, that is awesome. Let's focus on cyber physical security pilot in that community college. So I think the way to do this, and that's what we were doing with that program, was find community colleges in the niche area that the community college specializes in and double down on it. And those niche areas happen to be strategic. And that I thought was very good. So that was a key takeaway from that program. And that program needs to be scaled up. And if I had to add another element to the program, it would be what you brought up in the question, that train the trainer and the adjunct, incorporating adjunct teaching. What if, Lester, what if we got all the ASME members to do the teaching in the United States? That would work as well, I think.
Chandrakant, it's been very inspirational talking to you. You know, for someone with your credentials, a member of the National Academy, fellow of multiple societies, I think it really serves as an example for someone like me. And I probably think that I'm somewhere in the third quintile of engineers. So someone like me who can see your example and the way that you've given back to the field, I think it's really inspirational. And I think the listeners on this installment of the ASME Insights have felt a little bit of that passion. So thank you so much for for joining us on the show today.
Yeah, thank you. And thank you to all the listeners. It's a pleasure to be here. And the reason I'm doing it is so we can achieve the scale that you brought up.
So Chandrakant, I'm glad that you were able to share these thoughts with us, especially for those that were unable to see your keynote address at the IMechE in Memphis. And for the rest of our listeners who would like to hear more about ASME events and upcoming ASME content, you can always find that at asme.org. So take care, everyone.